My name is Ray Heimstra and I'm with Orange County Coastkeeper. We're here tonight as members of the Citizen Watershed Monitors of Orange County, CMOC. And what we're doing is we're getting ready for California Coastwide Snapshot Day, which is going to occur on May 7th, about a week and a half from right now. So to prepare for Snapshot Day, we have all of the groups who are going to participate. There's about 5 different environmental groups who are going to participate in this event. They're all here tonight with their equipment to go ahead and test it, make sure that it's all reading properly. So what we've done is we've set up different stations here for conductivity, pH, dissolved oxygen, and different nutrients that we test for. And everybody's got their equipment out to make sure it's working properly, and they're going to test the standards we put out to make sure that it's all getting the correct reading for Snapshot Day. And then when we go out that day, we'll have great readings from everybody, and we'll all feel confident that that's what it wants. Okay, what we have here is a dissolved oxygen and temperature stations. So what we want to do is we want to be able to, this is a dissolved oxygen meter right here. So what we want to do is we want to be able to calibrate this meter, make sure that it's working properly. Right now it's in an ice bath. What we have is we have some water that's had some ice melting in it for quite a while. And the idea is to get a temperature as close to 0 as possible. So this is the temperature one. This one happens to be reading 1.9. That's pretty good. That's about within the range that we could expect. So we record that on a piece of paper, and then we also have over here, this is the actual dissolved oxygen. This has an aquarium pump that's hanging there from the wall, and it's running bubbles through the water. The idea is to get 100% saturation on this, and 100% saturation is the high end of dissolved oxygen. So we put the meter in there, get the 100% saturation reading hopefully. The last one was 98.8% saturation, that's very good. And then also we use that for ambient water temperature. So we have the temperature already taken of that water, and we see if our temperature works well on that. What we have here is our nitrate test, and this is our reagent right here. This is our nitrate standard. This is what we measure nitrate with, and along with the other nutrients, which are phosphate and ammonia, all 3 of them are basically run by the same procedure. You collect a sample, you add a reagent to create a color change, and then you read it with the colorimeter. What the colorimeter does is it shoots a beam of light through the sample, and it reads the absorption of that beam of light, and it can tell how much sample is in there. So to go ahead and start this one, I'll open up my standard here, which is a blind standard. I don't know what this is. This is my reagent inside this little vacuum tube. There's all kinds of different ways to do this. Some people add chemicals and reagents. This particular one is a vacuum tube, so it's going to suck the water in. I'm going to stick it in here, break it off, and it just sucked in the correct amount of water. I already have my colorimeter set for nitrate. I'm going to press my timer, and I'm going to shake this for 1 minute. Okay, so what we've been doing, we've been waiting for about 5 minutes after I got done shaking it for 1 minute. That's the way this procedure for this particular test worked. And then we're going to go ahead and read the sample. First we have to zero it. We have some creek water here that we're going to use. If there was any color in the creek water, when you zeroed it, the machine would adjust itself with the natural color of the creek water. And then we're going to go ahead and use our sample, take the test of that. Using glassware, you're going to shoot a beam of light through it. Always make sure it's nice and clean. Any kind of fingerprints or watermarks or anything like that that's on your glass is going to affect that beam of light in the shot. So we're down to 9 seconds. And we're going to go ahead and get ready to do our thing. Put my zero sample in there, cover it up to keep any light out of it. There's my beep, so I'm going to press 0. The colorimeter is now shooting a beam of light through there, and it read 0, so that's great. Now I'm going to go ahead and grab my clean bottle, press read. Came up with 3.3 milligrams per liter. We press read again. We're going to do this 3 times. With colorimeters, you always want to do it 3 times. It's got 3.3 again. And 3.2, and then that's what you're going to record on your sheet. You're going to have the 2 3.3s and the 3.2. That's very good. It's a nice solid number. It's actually a little bit out of what we were looking for, but it's fairly close. Okay, what we have here is our test for phosphate. So this is basically the same procedure as we used in nitrate with the colorimeter. We're going to add a reagent to some water, and we're going to use the colorimeter to shoot a beam of light through it and measure the absorption. Color change is going to be a little bit different on this. If we find some phosphate, there's going to be a blue color. So we have our blank. We always need to have a blank for your tests. And then this is our sample, which is our standard tonight. So I'm going to go ahead and add the reagent. In the last one we had a vacuum ampule which sucked the water in. This time we're going to add the reagent to the water. So we add that reagent, put the cap on. The procedure calls for shaking it up for about 15 seconds. And that's good. I'm now going to press my timer and enter, and I have a 2-minute wait period where this is going to go ahead and turn blue. Okay, we're just about, our timer's just about to go off. There we go. So we're going to take our sample blank, make sure once again that it's nice and clean, because this is going to zero the machine in case there's any natural color to the water. We press 0. Okay, it's zeroed. Now I'm going to get my sample, put that in there. I'm going to press read. I have my result, which is 0.05. I'm going to read it again. So you're always going to do that 3 times. So that's the procedure for the phosphate test. Now the next one we have over here is ammonia. Basically it's the exact same test. You have your two vials with your water sample. We're going to use a different set of reagents. Ammonia is slightly different in that you add reagent to both your blank and your sample to create a specific color for it to zero the machine at. Other than that, you have a different waiting time. It's a 12-minute test, so we don't want to sit here for 12 minutes waiting for that. And then you just go ahead and do the procedure, same procedure. You're going to zero it, and then you're going to read your machine. Okay, what we have here is our pH station, and what pH measures is the alkalinity or acidity of the water. We have 3 different standards that we have set up here. There's different pH meters. The one that we have is called a pH 3, and the reason it's a pH 3 is because it takes 3 standards to calibrate it. So what I'm going to do is going to turn it on, open the top here on one of our standards. These are blind standards, so I don't know which one it is. Then I'm going to stick my pH meter in here, and it's going to take just a little bit for it to read. And then if it reads within the range that we're looking at, which is plus or minus 0.1, then it'll be okay. And if it's not, then we're going to go ahead and calibrate the meter from that point on. And we're going to move on to each of the other 2 standards to calibrate it at 3 different points.
My name is Eric Burris. I'm with the State Water Resource Control Board's Citizen Monitoring Team, the Clean Water Team. One of the things that we like to facilitate are intercalibration events and snapshot events. The 2 go really well together. Intercalibration events are like synchronizing your watch. What happens is that everybody that's going to go out to the field calibrates their equipment or performs a water quality monitoring test to a similar standard. That way everybody's starting at the same place. It can be pH, temperature, conductivity, even nutrients. As you can see behind me, we have a beautiful wetland, and it receives water coming off of an urban landscape that's typically high in nutrients. If we can get the information on whether or not the nutrients are high, low, or non-detectable, then we can institute appropriate management plans to make sure that the wildlife is protected. It's like going to the doctors for one day. Instead of taking the watershed to the doctors, we'll be like the doctors going out and performing that checkup test. So we'll know what the water was like that one particular instant in time. We want to protect not only beneficial uses for people, but beneficial uses for wildlife. doing these snapshot events, we're getting a clue into the watershed to see what's going on. By doing it with citizens, it empowers us even more. It's data and activism together.
One thing left I could embrace, it'd be your face, it'd be your grace. When I think I drown in all my sin, I take you in like